Hi students, in this video we will discuss some problems on functions. Exercise 1a, sixth problem. If a equal to set 1, 2, 3, 4 and f from a to r is a function defined by f of x equal to x square minus x plus 1 by x plus 1, then find the range of f. Here given that a equal to 1, 2, 3, 4. And the function f from a to r is a function defined by f of x is equal to x square minus x plus 1 by x plus 1. Substitute a values instead of x 1 by 1. F of 1, if x is equal to 1, then substitute x value in right side also. 1 square minus 1 plus 1 by 1 plus 1, which is equal to 1 square equal to 1, 1 minus 1 plus 1 cancelled. So 1 by 2, the result is 1 by 2. The second one, f of 2. If x is equal to 2, then f of 2 equal to x square. Substitute x is equal to instead of x. 2 square minus 2 plus 1 by 2 plus 1, which is equal to 2 square gives 4, minus 2 plus 1 gives minus 1. 4 minus 1 by 3. Minus 2 plus 1 gives minus 1. 2 square is 4. 4 minus 1 by 3. That is equal to 4 minus 1 is equal to 3 by 3 equal to 1. That is 1 is mapped to 1 by 2 and 2 is mapped to 1. And if x is equal to 3, then f of 3 equal to substitute x value, x is equal to 3 in RHS. X square, that means 3 square minus 3 plus 1 by 3 plus 1, which is equal to 3 square 9, minus 3 plus 1 is equal to minus 2. So 9 minus 2 by 3 plus 1 4, that is equal to 7 by 4. If x is equal to 4, if x is equal to 4, then 4 square minus 4 plus 1 by 4 plus 1. That means substitute x is equal to 4 in this. You get 4 square minus 4 plus 1 by 4 plus 1, which is equal to 4 square equal to 16 minus 4 plus 1 equal to minus 3 by 5. That is equal to 16 minus 3, 13 by 5. So 4 is mapped to 13 by 5. The set of all elements in domain are mapped to 1 by 2, 1, 7 by 4 and 13 by 5. So these elements are called a range of f. So therefore range of f equal to what? Range of f equal to set 1 by 2, 1, 7 by 4, 13 by 5. Seventh problem. It is important for IPE also. If f of x plus y is equal to f of xy for every x comma y belongs to R, then prove that f is a constant function. Solution. What is the given condition? F of x plus y is equal to f of xy for every x comma y belongs to R. Write the given information first. That means for any two real numbers, for every x comma y belongs to R means what? For any two real numbers, this is true. F of x plus y is equal to f of xy. Let us suppose y is equal to 0. Since 0 is a real number, you can take y as 0. So, substitute y equal to 0 in this above condition. F of x plus 0 equal to f of x into 0. So, x plus 0, x. F of x equal to x into 0 gives 0. F of 0. For every x belongs to R. This is true for every x belongs to R. Let us observe this. F of x is equal to f of 0 means what? The image of x is f of 0. Image of x is f of 0. Let us suppose this is domain and this is codomain. In the domain for every x, what is the image of x? F of 0. For every x. That means For all real numbers, or every x belongs to R means what? For all real numbers in the domain, for all real numbers in the domain, there exists a constant f of 0 in the codomain, such that f of x equal to f of 0. Understood? That let us suppose f of 0. What is f of 0? F of 0 means image of 0. F of 0. 0 is mapped to f of 0. But by this condition, what we conclude? F of x is equal to f of 0 means for every x there exists a value, a constant f of 0 such that f of x is equal to f of 0. For every x it is equal to f of 0. That means all elements in domain are mapped to f of 0. That means what? Definition of constraint function is for every x belongs to domain, there exists a constant in codomain such that f of x is equal to that constant c. In the same manner here, the function is defined like this. F is a function such that f of x is equal to k for every x belongs to R. Understood? For every element in R, there exists a constant k such that f of x is equal to k. So f is called constant function. So f can be, by the definition of constant function, f is said to be a constant function.
We are going to learn what are the proofing techniques for one function and proofing techniques for onto function. That means you know the definition of one function, but how to prove one in our problems. If the function is a finite function, that means the function f is defined on finite set. Then how to show f is 1. Simply find the f. That means substitute the domain values in the function defined and get the values of f. Draw pictorial representation. If no two elements of domain goes to the same element in the codomain, then the function is 1. That means if the pictorial representation is like this, it is 1. If it is not like this, that means two elements goes to the same element, it is not 1 function. Okay. In this manner, you can find the function is 1 or not for a finite function. When the function is a finite function, it is easy to represent it in pictorial. But if f is infinite function, that means it has domain with infinitely many values. You cannot be pictorially try to see are there two elements are pointed to same element. It is pictorially impossible to check this for infinitely many elements. So there is a proof technique. When f is an infinite function, f from a to b is a function. To show f is 1, let us simply assume f of x1 is equal to f of x2. That means for two elements, the image of two elements are equal. F of x1 equal to f of x2 means what? The image of x1 and x2 are equal. Then you have to show that the elements are equal. x1 is equal to x2. If it is possible, then we can say that f is 1 function. Proof technique for onto or surjection. When f is finite function, that means the function f is defined on finite sets. Here a and b are finite sets, so f is called finite function. For this case, to show f is onto, simply find f. How to find f value? Substitute all the values, that means all elements of domain in the function f. then the resultant values represent range of f. If range of f is equal to codomain, then f is called onto function. If range of f is equal to codomain, then f is an onto function or surjection. That means no element in codomain is left. Okay, here in case of range of f is equal to codomain, no element is remaining in the codomain. Okay, if f is an infinite function, f from a to b is a infinite function. That means here the function f is defined on infinite sets. Then how to prove f is onto? To prove f is onto, let us take an element y from codomain and let us suppose f of x is equal to y. Suppose f of x is equal to y and write the x value in terms of y. Now let us remember this value, x value in terms of y. Then write this procedure. For every y belongs to b, there exists an element, this x, not x, in terms of y. The value of x in terms of y belongs to a, such that f of x, here x means what? Write the x value in terms of y, x value in terms of y. This value, write this value here and get the value f by substituting the value in our given function. Okay, if you get y, then we can say that f is onto function. Okay, if you take an element y from codomain, there exists an element in domain such that f of x is equal to y. If you prove this one, we can say f is onto function. F is onto function. Okay. Second Roman first problem. If a equal to set of all x such that minus 1 less than or equal to x less than or equal to 1, f of x is equal to x square and g of x is equal to x cube, which of the following are surjection? Okay. F from A to A is a surjection or G from A to E is a surjection. We have to verify F is a surjection or G is a surjection. Given A equal to set of all x such that minus 1 less than or equal to x less than or equal to 1. This means what? The x values are from ranges from minus 1 to 1. That means A equal to closed interval minus 1 to 1. We can write minus 1 less than or equal to x than less than or equal to 1 as closed interval minus 1 to 1. The values of A are in between this interval. Now we have to prove that the function f from A to A is surjection or not. Let us verify. Given what? F is a function from A to A defined by f of x is equal to x square. Let us denote this by pictorially. Draw this diagram. F is a function from A to A. X is equal to f of x is equal to what? X square. So x is mapped to x square. The image of x is x square. Now let us take some elements in this interval. A equal to closed interval minus 1 comma 1. To find the values of f, let us substitute some of the values in this interval. Let us take minus 1. F of minus 1 is equal to what? Minus 1 whole square, which gives what? 1. Minus 1 whole square gives 1. Negative value, if you squares any number, then it gives only
positive value. What if you square any number, negative number or positive number, the result must be positive. So f of minus 1 is equal to minus 1 whole square is equal to 1. Now take x is equal to minus 0.5. Now f of minus 0.5 gives what? Minus 0.5 whole square equal to 0.25. F of 0 equal to 0 square equal to 0. And f of 1 is equal to 1 square is equal to 1. By this result, what we conclude that minus 1 is mapped to 1, minus 0.5 is mapped to 0.25, 0 is mapped to 0, 1 is mapped to 1. So understand this diagram. F of x is equal to x square means what? The image of x is x square. Now from the values of f, minus 1 is mapped to 1, minus 0.5 is mapped to 0.25, and 0 is mapped to 0, and 1 is mapped to 1. Let us observe. If you take any negative value in the domain, it will be mapped to positive values in the codomain. Understand carefully. X is mapped to x square means what? If you give input value, then it squares that value and gives output. Understand? Here I am giving minus 1, and if it squares minus 1, it gives a positive value 1. If I give minus 0.5 as input, it squares that the function squares this number, this element 0.5 minus 0.5 and gives the positive element 0.25. That means all the negative values in the domain are mapped to codomain. So here there are no pre-images for the negative values in the codomain. Understand? For the negative elements in the codomain, there are no pre-images. That means negative values are left in the codomain. Left in the codomain. All the negative values are left in the codomain. So range of f never be equal to codomain. Range of f never be equal to codomain. That means what is range here? Range started from 0 to and ends with 1. Started with 0 and ends with 1. So what is the range of f? Closed interval 0 comma 1. Closed means what? It includes the extreme values also. It includes the range of f includes 0 and 1. Here observe, we have 0 and 1. So we take closed interval 0 comma 1. Okay. Now range of f not equal to codomain. So we can say that the function f is not a surjection. Now show that G is a surjection or not. Verify it. Let us take G is a function from a to a defined by g of x is equal to x cube. Given this, G is a function from a to a defined by g of x is equal to x cube. A is given that set of all x such that minus 1 less than or equal to x less than or equal to 1. So A can be written as closed interval minus 1 comma 1. That means A take values from this interval, all values from this interval. Okay, now let us see the pictorial representation of the function. G is a function from a to a. G of x is equal to x cube. So the image of x is x cube. If you give any input, it cubes that input value and gives the output. Let us take some elements in this interval. Let us take x is equal to minus 1. G of minus 1 is equal to minus 1 whole cube, which gives minus 1. Why this? Because let us observe this one. Minus 1 whole cube equal to minus 1 into minus 1 into minus 1. Minus and minus gives positive. So minus 1 into minus 1 is equal to plus 1, which again multiplies with minus 1 gives minus 1 only. So g of minus 1 equal to minus 1 whole cube, which is equal to minus 1. That means minus 1 is mapped to minus 1. If you take x is equal to 0, then g of 0 equal to 0 cube, which is equal to 0. So 0 is mapped to 0. And if you take g of 1, 1 cube is equal to 1, then 1 is mapped to 1. If you take x is equal to minus 0.5, then g of minus 0.5 is minus 0.5 whole cube, which is equal to minus 0.125. That means minus 0.5 is mapped to minus 0.125. Understood pictorially. Here, all the elements in the domain have elements or images in the codomain. Here, no element is left. Here, no element is left in the codomain. Understood carefully. All the, for every negative value, it has images in the negative values. All the negative values taken in the domain have pointed to negative values only. Understood? That means every element in the codomain has pre-image in the domain. Understood? Every element in the codomain has pre-image in the domain. That means all the range is in between minus 1 and 1. Range is in between minus and 1. So we can say that range of G is equal to closed interval minus 1 comma 1. Since range started start from minus 1 and ends with 1, we can say range of G is equal to closed interval minus comma 1 comma 1. Closed interval minus 1 comma 1. Observe this A equal to minus closed interval minus 1 comma 1, and range of G is also closed interval minus 1 comma 1. Therefore, we can say that range of G is equal to codomain. In this case, we can say G from A to A is surjection. Okay. We will discuss other problems in next video. Thank you.